We'll start in 1 minute. Today we'll cover the second part of section 6.5 on solving polynomial equations by factoring with applications. Remember, on Monday and Tuesday of next week, we will review for test 2, and test 2 will be on Wednesday of next week. Okay, to solve application problems, follow these steps. Read the problem. Sometimes you might need to read the problem more than once in order to understand it. Then identify what needs to be found. Assign variables for what needs to be found. Use the given information and the variable assignments to formulate an equation, and then solve the equation and check the solution. Okay, the first problem, the product of two consecutive even integers is 224. Find two sets of solutions. Okay, well, the product of two numbers is what you get when you multiply them. And we want to multiply two consecutive even integers. And then the product will be 224. And then it says find two sets of solutions. So what that means is one set of solutions will be two consecutive even positive integers, and the other set of solutions will be two consecutive even negative integers. Okay, well, how do we represent two consecutive even integers? Well, even integers, a pair of consecutive even integers, differ by 2. The positive even integers are 2, 4, 6, 8, 10, and so on. The negative even integers are -2, -4, -6, and so on. 0 is considered an even integer, but a pair of consecutive even integers differ by 2. So how do we represent algebraically a pair of consecutive even integers?
X plus 2.
Okay, so yeah, well, that's one of the integers. What's the other one? Because we want to represent two integers that are consecutive. So you're onto something there. We can say x and x plus 2 represent two integers that are even and consecutive. So x and x plus 2, this is how we're going to represent two consecutive even integers. Okay, and we're told that the product is 224, so our equation is x times x plus 2 equals 224. That is our equation. So let's just check the details. Consecutive even integers differ by 2, so x and x plus 2 differ by 2. And the product of those consecutive integers is 224. So everything seems to check out. Now all we have to do is solve this equation. Well, if we multiply x times the binomial x plus 2, we get x squared plus 2x. And x squared plus 2x equals 224. Yesterday, we discussed how to solve equations by factoring. So let's try to solve this by factoring. We want one side to be 0, so we'll subtract 224 from both sides. And we get x squared plus 2x minus 224 equals 0. And now we'll try to find the factors of x squared plus 2x minus 224. The greatest common factor of the three terms is 1. So when we use the AC method, we start by multiplying 1 times negative 224, and we get negative 224. Okay, so the next step in the process, we want to find two integers that have a product of negative 224 and a sum of positive 2. So let's do the systematic approach to see if we can find the integers. Two integers that have a product of negative 224 and a sum of positive 2. Well, I don't have a lot of space here, so I'm going to use another piece of paper. So it was 1 times negative 224 equals negative 224. Two integers that have a product of negative 224 and a sum of 2. Well, if the product is negative, one must be positive and one must be negative. If the sum is positive 2, then the one with the largest absolute value is positive. In our systematic approach, then, we write at the extremes negative 1 times positive 224. The next pair is negative 2 times 112. Negative 3 is not a factor, but negative 4 is a factor. Negative 4 times 56. Negative 5 is not a factor. Negative 6 is not a factor. But negative 7 is. Negative 7 times 32. Negative 8 and 28. Those add up to 20. We're getting closer. So let's see, negative 9 is not a factor. Negative 10 is not a factor. Negative 11 is not a factor. Negative 12 is not a factor. Negative 13, no. Negative 14, negative 14 times 16. Okay, so those are the two integers, negative 14 and 16. We'll go back to the other page. Okay, so negative 14 and positive 16. So transform the trinomial into a quadrinomial, x squared minus 14x plus 16x minus 224 equals 0. Out of the first two terms, factor out x. So we get x times x minus 14. Bring down the middle operator of addition. Out of the third and fourth terms, we factor out positive 16. And the other factor is x minus 14. And then we factor x minus 14 times x plus 16 equals 0. Okay, the two solutions to this equation are x equals 14 and x equals negative 16. Okay, so the two sets of solutions. So one set is 14, x equals 14, and remember the other factor is x plus 2. And 14 plus 2 is 16. So one set of solutions is 14 and 16. Those are consecutive even integers with a product of positive 224. And the other set of solutions is when x is negative 16, and negative 16 plus 2 is negative 14. So negative 16 and negative 14 make up the second set of consecutive even integers that have a product of 224. Okay, let's move on to the next problem. This one says a ball is thrown upwards from the roof of a building. And we're told what the height is of the ball. So a ball thrown upwards from the roof of a building is h of t equals negative 16 t to the second plus 32 times t plus 48 feet above the ground after t seconds. Okay, so when t is 0 seconds, the height of the ball is 48 feet above the ground. And after 1 second, the height of the ball is, well, you would find it by replacing t with 1. So after 1 second, the height of the ball is negative 16 times 1 plus 32 times 1 plus 48. Or that would amount to 64 feet above the ground. So this sort of equation you might not have seen before. But this equation just tells us what the height of the ball is above the ground t seconds after it is thrown upwards. Does that seem to make sense? Yeah, it's called a function of the variable t, and t just represents numbers that could start at 0, and then after that they are positive. Okay, so the directions say find the 0 of the function. So that might be a new concept for you. So the 0 of a function, this is a function of the variable t. So the 0 of a function is, in this case, it's the t value that makes the output equal to 0. Okay, let's read the rest of the sentence. Find the 0 of the function, which is the number of seconds it takes for the ball to hit the ground. Okay, so a ball is thrown upwards from the roof of a building, and the height of the ball above the ground, t seconds after it's thrown upward, is given by this formula. The height after t seconds is negative 16 t to the second plus 32 t plus 48 measured in feet. Okay, well, at some point, if there are no other obstacles in the way, at some point the ball is going to hit the ground. And when the ball hits the ground, its height above the ground is 0 feet. So in other words, find the value of t when the height, h of t, is equal to 0. Okay, so all we have to do then to answer this is replace h of t with 0 and solve the resulting equation. So 0 equals negative 16 t to the second plus 32 t plus 48. When we solve for t, that will tell us how many seconds it takes for the ball to hit the ground after it's thrown upwards. When the ball hits the ground, the height is 0 feet. Okay, any ideas on how to solve this equation for t? Well, the topic as of late in recent days has been solving equations by factoring. So if we solve an equation by factoring, we want one side to be 0, and we have that. And then we want to see if we can factor the other side. The greatest common factor of the three terms in the trinomial, the greatest common factor is 16. But my general advice is that if the leading coefficient is negative, then factor the negative of the greatest common factor out of all three terms. So if we factor negative 16 out, we get negative 16 times, well, negative 16 t to the second divided by negative 16 is t to the second. Positive 32t divided by negative 16 is negative 2t, so we write minus 2t. And 48 divided by negative 16 is negative 3. Hey, another thing you can do, which I explained a couple of times already, if we have an equation, we are permitted to divide every term on both sides by the same non-zero number. So if we want, we can divide every term on both sides of this equation by negative 16, whether it's in this partially factored form or not. So if we divide every term on both sides by negative 16, 0 divided by negative 16 is still 0. And then we're just left with 0 equals t to the second minus 2t minus 3. So you might agree that looking at this equation, 0 equals t to the second minus 2t minus 3 looks less intimidating than the equation above it. The solutions to both of those equations are the same, but the one on the bottom is we have clutter that we got out of the way, so this will be easier to work with. Well, you can pretty much tell by looking what the factors are. So why don't you take 10 or 15 seconds and find the factors, and you can type those in online. Okay, what are the two factors? T plus 1 and t minus 3. Okay. T minus 3 and t plus 1. Okay, those are the two factors. The two solutions to this equation are t equals positive 3 and t equals negative 1. But in this particular problem, the negative value for time doesn't make sense. So our answer is t equals 3 seconds. So to summarize the result, we can say the ball hits the ground uh, 3 seconds after being thrown upward. Okay, let's move on to the next problem on the next page. This one, the hypotenuse and the longer leg of a right triangle are 9 feet and 7 feet longer than the shortest leg, respectively. Find the length of the three sides. If we draw a right triangle just to aid, so the hypotenuse is 9 feet longer than the short leg, and the longer leg is 7 feet longer than the shortest leg. So since the hypotenuse and the long leg are described in terms of the short leg, we can assign a variable for the short leg. So I'll assign x to be the length of the short leg measured in feet. So the short leg is x feet. The long leg is x plus 7 feet. And the hypotenuse is x plus 9 feet. Hey, so in our right triangle, the hypotenuse x plus 9, the short leg x, and the long leg x plus 7. Okay, so to find the lengths of the three sides, we can apply the Pythagorean theorem. So a reminder of the Pythagorean theorem. Which applies to all right triangles. If you have a right triangle, if the two shorter legs or the two shorter sides are length A and B and the hypotenuse is length C, then the sum of the squares of the two legs is equal to the square of the hypotenuse. Okay, so we apply the Pythagorean theorem to this right triangle. So if we square the short leg, x squared, and add that to the square of the long leg, so this is x plus 7 quantity squared, that will be equal to the square of the hypotenuse, or x plus 9 quantity squared. Okay, so we get this equation. So for this kind of polynomial equation, the only method that we've discussed for solving a polynomial equation is to solve it by factoring. Okay, so we should multiply everything out. When we square the binomial x plus 7, we get x squared plus 14x plus 49. And on the right-hand side, we'll square the binomial x plus 9. That means x plus 9 times x plus 9, so we get x squared plus 18x plus 81. So in the next step, let's make the right-hand side 0. So we'll subtract 1x squared from both sides. That will leave us with 1x squared on the left-hand side. Then we will subtract 18x from both sides, so that on the left-hand side we have minus 4x. And then we're going to subtract 81 from both sides. 49 minus 81 is negative 32, so we have minus 32 equals 0. Okay, so now we'll try to factor x squared minus 4x minus 32. Okay, it doesn't take too long to find the two factors. One factor is x minus 8, and the other factor is x plus 4. So the solutions, if x minus 8 is a factor, I'll go ahead and write the details. We set each factor equal to 0. So if x minus 8 is 0, x equals 8. And if x plus 4 is 0, x is negative 4. Okay, but in our problem, x has to be positive, so we omit the negative solution, and we're going to use x equals 8. Okay, so the short leg is x equals 8 feet. The long leg is, we assigned x plus 7, so 8 plus 7 is 15 feet. And then the hypotenuse, our variable assignment for the hypotenuse is x plus 9. So 8 plus 9 is 17. So the hypotenuse is 17 feet. Okay, the next problem, the product of two integers that differ by 4 is 221. So how do we represent the two integers if they differ by 4? We can say x is one of those integers, and how can we represent the other integer?
X plus 4.
You can use x plus 4. That's not the only way to do it. You could also write x minus 4. Either way, you'll end up with the correct integers. Just make sure that your variable assignments make sense. So x and x plus 4 differ by 4, and the product is 221. So that means when we multiply x times x plus 4, we get a product of 221. Okay, so we'll multiply x times x plus 4. We get x squared plus 4x equals 221. And then we'll attempt to solve this equation by factoring. So we'll subtract 221 from both sides. And we get x plus 4x minus 221 equals 0. And now we'll try to factor the left-hand side. Whoops, that's supposed to be x squared plus 4x minus 221. The greatest common factor is 1. So in the AC method, we multiply 1 times negative 221. To get negative 221. So two integers that have a product of negative 221 and a sum of positive 4. If the product is negative, one must be positive, one must be negative. If the sum is positive, the one with the largest absolute value is positive. So at the extremes, we write negative 1 times positive 221. Well, let's see. 2 is not a factor. 3 is not a factor. Or negative 4 is not a factor. Or negative 5 is not a factor. Negative 7 is not a factor. Negative 8 is not a factor. Negative 9 is not a factor. Negative 10. Negative 11, no. Negative 12, no. Let's see, 13, negative 13. Yeah, I think that one works. So if I divide 13 into 221, 13 goes into 22 once. 22 minus 13 is 9. And 13 goes into 91 7 times. So negative 13 times positive 17. And those two numbers add up to 4. So negative 13 and positive 17. Those are the two numbers. Okay, so transform the trinomial into a quadrinomial, x squared minus 13x plus 17x minus 221 equals 0. And then factor by grouping. Out of the first two terms, factor out x, and we get x times x minus 13. Bring down the middle operator of addition, and 17 is the greatest common factor, so we factor out 17 and get x minus 13. And then the two factors are x minus 13 and x plus 17. So set each factor equal to 0. X minus 13 is 0, and x plus 17 is 0. So one of the solutions is x equals 13. The other one is x equals negative 17. We do have two sets of solutions. It didn't ask for two sets of solutions in the directions, but if x is 13 and the other number 13 plus 4 is 17, so 13 and positive 17 is one pair of solutions. They differ by 4, and they have a product of positive 221. And negative 17 and negative 17 plus 4, or negative 13, that is the other set of solutions. Okay. The next problem, for now, let's bypass this one. This is similar to the previous one. It's just that this time the product is negative 45. But the procedure is very similar to what we did on the previous example. So let's go ahead and move to number 6. Okay, this one says the area of a rectangle is 432 square feet. And the length is 6 feet longer than the width. Find the length and the width. Okay, a reminder, if you have a rectangle, then the area of the rectangle is found by multiplying the length times the width. So the area is length times width. Okay, so we have a particular rectangle. We're told that the area is 432 square feet. And then we're told that the length is 6 feet longer than the width. Well, if we assign the width to be x feet, then what's the length? We're given that the length is 6 feet longer than the width. So if the width is x feet, then the length is x plus 6 feet. And now we can write down an equation with our variable assignments and the other information that's given in the problem. If we multiply the length times the width, so x plus 6, multiply that quantity by x, we're given that the area is 432 square feet. Okay, so here is our equation. We'll multiply the binomial x plus 6 times x, and we get x to the second plus 6x equals 432. Subtract 432 from both sides, x squared plus 6x minus 432 equals 0. And then we solve by factoring. So did you already find the factors? Take a minute to see if you can come up with the two factors for x squared plus 6x minus 432. Okay, I got an answer online. Okay, let's go through the systematic approach for factoring. The greatest common factor is 1. And then the AC method, we multiply 1 times negative 432, which is negative 432. Find two integers that have a product of negative 432 and a sum of 6. Okay, so one must be positive, one must be negative. The one with the largest absolute value is positive. So we start at negative 1 times positive 432. The next factor, negative 2 times positive 216. Negative 3 times 144. Negative 4 times 108. Negative 5 is not a factor. Negative 6 times 72. Negative 7 is not a factor. Negative 8 times 54. Negative 9 times 48. Those add up to 39. Negative 10 is not a factor. Negative 11, no. Negative 12 times 36. Negative 13, negative 14, no. Negative 15, negative 16. So negative 16 and 27, those add up to 11. So negative 17 is not a factor. Negative 18 times 24. Those do add up to 6. So negative 18 and 24. Okay, so transform the trinomial into a quadrinomial. Replace the plus 6x with minus 18x plus 24x. And then factor by grouping. Out of the first two terms, factor out x. So we get x times x minus 18. Bring down the middle operator of addition. And then out of the third and fourth terms, factor out 24. So 24 times the binomial x minus 18. And then our two factors, x minus 18 and x plus 24. Okay, the two solutions are positive 18 and negative 24, but the solution we want is positive 18. So the width is 18 feet, and the length 18 plus 6 feet, or 24 feet. And you can always check, make sure that the width and the length satisfy the conditions. The length is 6 feet longer than the width, and when you multiply 24 and 18, you get an area of 432 square feet. Okay, let's set up the next problem. We're almost out of time, but we can set up this problem. The product of two consecutive odd integers is 143. Find two sets of solutions. So how do we represent two consecutive odd integers? So an example of two consecutive odd integers is 11 and 13. That's one example of consecutive odd integers. So how do we represent them with variables?
Wouldn't that still be like x and x plus 2?
Yeah, x and x plus 2, or x and x minus 2. I'll just say x and x plus 2. Because consecutive odd integers differ by 2. And then the product is 143. So we multiply x times x plus 2 and get a product of 143. We'll take this a little bit further. Multiply the x times x plus 2 to get x squared plus 2x. equals 143, and then subtract 143 from both sides, and then solve by factoring. Okay, we still have a few seconds left. On the next one, number 8, the length of a rectangle is twice as long as the width, and the area is 288 square feet. So if we assign the width to be x feet, and the length is twice as long as the width, then the length is 2x feet. And then the area is 288 square feet. So if we multiply length times width, we get the area, or 2x squared equals 288. And this one's pretty easy to solve. Just divide both sides by 2 and then find the positive square root for x. Okay, we're out of time. So go ahead and sign in for attendance.
So with questions like number 6, when you're using the AC method, are you able to check that you got the right numbers in the end of what integers you have?
On number 6?
Yeah. I noticed here, the numbers in the end were the same that we found in the AC method. Is that a way to check it?
Yeah, that's true.
Is that
There is an abbreviated AC method, and I haven't explained the abbreviated AC method yet. But if in your quadratic equation, if the coefficient of x squared is 1, then when you find the two integers, so one of the integers is negative 18 and the other one is positive 24, then you can just automatically say that one of the factors is x minus 18, the other one is x plus 24.
okay?
That abbreviated method only works when the coefficient of x squared is 1. But it always works. But I'm going into more detail just to.
I like detail. I was just wondering.
Okay.
Thank you.
Yep.
I was wondering if it was an imagined correlation or not. So
What's that?
I was wondering if it was an imagined correlation, or if it was something that would later come into play. How they wind up like that, or if it was just with this problem, if they would match like that later, if that makes sense.
I'm not sure I understand your question.
I was just wondering if it was something that my brain imagined would correlate, or if it would continue being like that, where the integers found with the AC method would line up with all problems, and that was something that I could make sure I didn't mess up.
Oh, yeah, the AC method is for quadratic equations. And if the solutions are rational numbers, then the AC method always works. But,
Wonderful. Thank you.
all right.